Hello guys, this is Ishan Akbar. In this video, I would let you know that how can we calculate or how can we assess or estimate the missing precipitation of any rain gauge station or any station within a catchment area when the rainfall of other rain gauge stations or other networks, other points within a network is given within a single catchment area. So for this purpose, I have considered a catchment area which is shaded green, and I have installed a network of seven rain gauges in this catchment area or in this watershed. So for this watershed, I have considered that there is a station which is denoted as X, which is unknown station. I mean, this is the station for which I don't know the precipitation for a specific period of time. To estimate the precipitation of this station, I would number the stations which are known: three, four, 5 and 6. It means that I have total number of stations in the rain gauge network in this catchment area, that is 6. The known precipitation for stations which are 6, the unknown station which for which we don't know the amount of precipitation is X. So basically, I am going to estimate the precipitation at station X when the precipitation of station 1 to station 6 is known. So for this, we can use two methods. The first method is known as the arithmetic method, and the second method is known as the normal ratio method. In this lecture, we will discuss both of them. The first one is very simple. So, what will we do for this one? Arithmetic method. We will simply calculate the average of rest of six stations. So, if we say that we are going to apply the arithmetic method for the calculation of unknown precipitation of station X when the precipitation for other six stations is known. So for this, we will use simple formula Px. Precipitation at an unknown station is equal to P1 plus P2 plus P3 up to so on, and P6 last station divided by the total number of known stations is 6. So simply we can say that the formula for precipitation of unknown station is summation of I is equal to 1 to n Pi. This is a generalized summation formula divided by total number of stations which are of known precipitation. So we'll simply put the value of P1, let us say this is 10, this is 12, this is 15, P4 is 14, P5 is 13, let us say, and P6 is 10 divided by 6. We'll simply add up these values, these six values, and we'll divide by 6. So it will give us, let us say this gives a value of 212.5 millimeter. So the units of these precipitations are in depth unit, millimeter. So we can say that the amount of precipitation at this station Px is equal to 12.5 millimeter. So this is the arithmetic method or arithmetic mean method to calculate the missing rainfall data for a station. And the second method is the estimation of missing rainfall data for a station by using normal ratio method. In this normal ratio method, we can use the formula for Px as 1 by n summation of nx over ni into pi. and when I ranges from 1 to n. So here in this case, nx and ni are two new terms, and we know from the previous case pi and n. So here again, this is unknown station. This is 1, 2, 3, 4, 5, and this is sixth station. So if we know the data of the six stations and we want to estimate the data of another unknown station, so we can simply use the normal annual rainfall of all the stations including X. So we'll use the normal annual rainfall of all the stations to estimate the missing data. So here Nx and Ni are the normal rainfalls. Nx is the normal rainfall of the missing station, while Ni will be the rainfall of relevant station. If we are using P precipitation of first station P1, then we will use the normal rainfall of first station N1. So if we are going to apply this scenario to this catchment area, this specific catchment area, Px will be equal to 1 by n divided by nx over n1 into P1 plus nx over n2 into P2 plus nx over n3 to P3 plus up to so on, and we will move towards sixth gauging station nx over n6 into P6. We just need to put the value 1 by this n means the known number of stations. These are six number of stations in total. Nx is given as 127 because this is the normal annual rainfall of the station X divided by what is normal annual rainfall of first station. This is 120 multiplied by the precipitation of first station. This is given as 10 plus 127 Nx, and N2 is given as 11 for B station. This is 11 multiplied by divided by the mean annual rainfall 115 into 11 plus nx is 127 again. In the numerator, nx will remain same for every part of the formula, divided by 138 multiplied by 115 plus up to so on. We will write these value in the same order plus what is nx, this is again 127. What is the normal precipitation for a year for the last or sixth station? This is 150 multiplied by the f precipitation for the specific time. So when we divide 127 by 120 and multiply by 10, then again same, we'll have six parts, and we will sum up these six parts and we'll divide by 6, and it will give an answer of say 12.5 millimeters. So these precipitations are given in millimeters, and normal precipitation is also given in millimeters. So unknown precipitation for the station X is 12.5 by the normal ratio method. Thank you very much. Take care. See you in the next video.